Now this is question number 35, objective solved examples functions module. Now in this question this property is given, and we have to find fx where fx is a polynomial. So we have to find a polynomial function that satisfies this property, right? So the solution, two approaches are given, and I'll be discussing the alternate approach because it's easier than the other approach, and we can do it the alternate approach because it is given that the function satisfying this property is a polynomial function. So we assume polynomial of degree n like this and replace here to get this fx f of 1 by x, product of the two, fx plus f of 1 by x. It's an identity as it is true for all values of x. So identity means this side, left hand side, is identical to right hand side, so all terms are same. So what we do in the first step, we see coefficient of x to the power n. How can we get coefficient of x to the power n? If you multiply this term with a constant term, that's the only way, a naught an, right? To get x to the power n term in the product of the two is when you multiply this first term with a constant term. On this side, coefficient of x to the power n is a naught. So this implies an equal to 1, right? We get an equal to 1. Now we compare coefficients of x to the power n minus 1 on two sides. Left hand side will get when we multiply x to the power n term with 1 by x term from this side. 1 by x term from this side is an minus 1 by x. So it is a naught into an minus 1. Another option is when I multiply this second term with a constant term, that is a1 an. That's all. Only two ways. Nth degree term with 1 by x term, and x to the power n minus 1 term with constant term. On this side, this is x to the power n minus 1 term, a1. Now if I look at this, an is 1, so I replace this equal to 1, and if I replace this equal to 1, then cancels out with this. So I get a naught an minus 1 equal to 0. A naught cannot be 0 because it is a degree n equation, so coefficient of x to the power n cannot be 0 by definition. So I get an minus 1 equal to 0. So right, so if we generalize this, we get a1 equal to 0, we get a2, a3, a4, all till an minus 1 equal to 0. So this polynomial becomes fx, takes this shape, a naught x to the power n plus 1. So if I just rewrite the same the given property, fx multiplied with f of 1 by x equals to fx plus f of 1 by x. Now I need to find a naught. To find a naught, I can compare constant term on two sides. Constant on this will be a naught square plus 1. Constant term from this side is 2. So this implies a naught square equal to 1. A naught equal to plus minus 1. So fx function is plus minus x to the power n plus 1. Now it is given that f6 equal to some, I'm not sure, wait, yes, f4 equals to 65. So using this we can find n. So replace x equal to 4, f4 equals to plus minus x to the power 4 to the power n plus 1 equal to 65. So plus minus x to 4 to the power n equals to 64. So only negative value won't satisfy this, only plus value will satisfy this, n equal to 3. So fx is x cube plus 1.